This is an example of random sampling where very few samples have been taken within the rectangular area, which are shown in a Cartesian coordinate over here. So from these sample locations, a gridded map can be prepared. But as the number of samples are very less, the accuracy level of the map, the continuous raster map, may not be so high. But at the same time, you see the distribution pattern of the samples. Here, throughout the area, the samples are well distributed. That is an advantage of getting better result. So, there are two factors. One is the density of the samples. Second is the distribution of the pattern of the samples. The sample location must be homogeneously distributed throughout the space. Depending on two factors, the interpolated map accuracy enhances. So, on the geometry of the samples and its values, numeric values, the quality of the interpolated map enhances. Now, if, as for example, we are going to map the copper concentration of the area from a particular medium, such as stream samples or bedrock samples, whatever it may be, we need to take as many as samples possible. But because of the feasibility problem, we cannot take. We are restricted to take few samples, random samples. So ultimately, the total area we divide into some rectangles or the cells, which is called grids. Now, in grid pattern of interpolation, the advantage is it is very easy to calculate mathematics, but the accuracy level is not good. If it is random samples and number of samples are restricted to a certain part of the area, the accuracy level is not so good because it is a non-adaptive method. Based on the number of samples only, the interpolation takes place. So I told you two factors. One is number of samples, another is the distribution pattern. Grid type of interpolation does not take into consideration the distribution pattern. Whereas in case of TIN method, what is TIN? Triangulated irregular network. Based on that particular method, the interpolation value is high. All the modern day surveying is done on the TIN method concept, triangulated irregular network concept. In the right side, you see the TINs. There are two things. The black dots are the sample points, and you have to prepare a theoretical and conceptual triangles. The triangle must be as close to a equilateral triangle. So within the equilateral triangle, all value will be interpolated. So individual equilateral triangle will be created and values within that triangle will be assigned for the particular area. And the complementary of the Delaunay triangle is called Thesian polygon. This polygon is drawn over here with the solid lines, and the triangles are drawn by the dotted lines. With these two concepts, grid concept and TIN concept, all the interpolation geometry is based. Here you can clearly see with the values of the attribute. It is also shown over here. Now I will come to the calculation pattern. Once the TINs or Delaunay triangles are created, we need to calculate the values. The value can be calculated based on the algorithm. If we adopt the deterministic algorithm inverse distance weight, we have to apply these two formulas. If it is a linear interpolation, then the Vx, you see, Vx is the unknown locations whose value I do not know. I know the values at V1 and V2 at a particular point, and the distance between V1 and Vx is D1 and Vx2, V2, D2. In that case, in a linear interpolation by IDW method, inverse distance weightage method, the Vx value will be V1 into D2 plus V2 into D1 divided by D1 plus D2. So these are very, very fundamentals of IDW in a very linear type of interpolation, which we used to do before the computerizations started. So in our college days, we used to use this type of interpolation. We never thought of the complex mathematics behind it, but we used to do it. Again, inverse distance, in addition to inverse distance, that is a very simple and fundamental process. We have got spline, radial basis functions, all sorts of different type of algorithms. In addition to the deterministic types of interpolation, we have got a probabilistic or statistical type of interpolation that is called Kriging. Kriging is based on the concept of geostatistics or variogram.